Bismillah ar-Rahman ar-Rahim. Now we'll continue doing this review for solving linear systems. We started with the meaning of linear systems, and we have mainly two methods: elimination method, the Gaussian elimination method. I think we did some examples about the Gaussian method, about the elimination method, where either we have a solution. We start 2 by 2, two equations, two unknowns. Either we get a solution, a unique solution, or have no solution, where I have 0 equal 5. That means there is something wrong. Or we get 0 equals 0, then we can write x in terms of y, so I have infinitely many solutions. And then we did this 3 equations, 3 unknowns. Then we'll continue. Okay, now, what's the idea there? I'll try to make the coefficient of x 0, 0, so that I have only 2 equations of y and z. Then I will do the same to make the coefficient 0, 0. I'll try to solve it by any way. And then, I'll try to eliminate a term, eliminate a variable. Like what we did now, these 2 equations, we eliminate the variable x. So I have only y and z. Then I will do the same for these 2 equations to eliminate, for example, eliminate z in the second equation. So we have only one equation with one variable, then we can solve it easily. And then we do back substitution to find the answer. Let me do this one. Okay. Now, if you look at this one, you notice the starting one, it's not 1. It's 2. But I have, this is the coefficient of x is 1. So what I will do, I will interchange these 2 equations. So I have the system x plus 3y plus 2z equals 2. I make this the first and this is the second. I interchange these 2 equations. 2x plus 7y plus 3z equal 11. And the last equation, the same. 3x and y plus 9z equals minus 12. Okay, I'll try to solve this system. This idea, I'll try to eliminate x. So I multiply by this, let me call it 1. This is 2. This is 3. So I multiply the first equation, minus 2 times the first equation, and I add it to the second equation. And minus 3 times the first equation, and I add it to the third equation. Let us see what will happen. So the first equation, it will not be changed. There is no change for the first equation. It will be the same. Multiply by minus 2 and add, so the coefficient of x will be 0. Minus 6y plus 7y, that will be y. Minus 4z plus 3z, that will be minus z, equals minus 4 plus 11, that will be 7. I just multiply the first equation by minus 2 and add it to the second equation. Okay, now do the same between the first and the third. Multiply the first equation by minus 3 and add it to the third one. So I eliminate x. Minus 9 plus 7y, that will be minus 2y. Then minus 6z plus 9z, that will be plus 3z equals. Now, multiply the first equation by minus 3, that will be minus 6, minus 12, minus 18. Now, if you look at these 2 equations, I can work them as to eliminate z, to eliminate y. I can do my calculation, do the same thing to eliminate y. So multiply this equation, just 2. Multiply 2 times 2 and add it to 3 to get rid of y. So what will be my new system? The first equation will be the same. The second equation will be the same. The one will change, which is the third one. Multiply by 2 and add 2y minus 2y gone. That is 0. Minus 2z plus z, 3z, that will be z, equals. Then we say minus, multiply by 2. 14 minus 14. 14 minus 18, that will be minus 4. That will be minus 4. What I will do now, I will do back substitution. I'll do back substitution to find the other variables. Okay, so I have z equal minus 4, plug it in the second. So I have y minus 4 is equal to 7. So y will be what? Y will be 7 minus 4, which is 3. Now plug z and y in the first one. That implies x will be equal to minus 3y minus 2z. And that is 2 minus 9 plus 8, which means it's 1. So what is my solution? Will be x equal 1. Oops. Y equal 3. And z equal minus 4. That's it. Okay, let me solve another one, 3 by 3. Okay, we'll do the same. I try to get rid of this 5 and this 8, huh? So multiply the first, let me do it right away, huh? X plus 5y plus 6z equals 3. Multiply by minus 5 and add, that is 0. Minus 25 plus 2, that will be minus 23y. Okay, big numbers, okay. Minus 30 minus 10, that will be minus 40z equals minus 15 plus 1 minus 14. Okay, now get rid of 8, multiply by minus 8, that will be 0. That will be minus 40 plus 17 minus 40 plus 17 plus 17, that will be minus 23. Yeah, same thing, minus 23y. Okay, minus 8 times 6 minus, that will be what? Minus 48 plus 8, that will be minus 40z. Interesting. Equals. Then I multiply minus 8 times 3 minus 24 plus 5, that is minus 19. Okay. Now I can deal with these two equations, like what we did before, and deal with these two equations to get rid of y or z. Okay, so if you look at it, yeah, you can do one trick. I can multiply the second equation by minus 1 and add it to the third. Let us see what will happen. You have 23y plus 23y. No, so the first one is the same. Huh? No change there. This one is the same. No. Okay. Multiply by minus 1 and add, that will be 0. Minus 1 and add, that will be another 0. Minus 1 and add, that will be minus 5. I have a problem here. Impossible that 0 equal minus 5. Like what happened in this case. Not in this case. So I have a conflict. So right away, that means we have no solution. What's the meaning of that? There is no way I can find 3 values, x, y, z, says that these values satisfy all of the 3 equations. Okay, let me move to the next one. Okay, yeah, we'll do the same. Try to get rid of minus to the, x in the second equation to see what will happen. Multiply by minus 2 and add, that is 0. By minus 2 and add, that will be 3y. Minus 2 and add, that will be minus 6z. By minus 2 and add, that will be 9. Okay. Now, by minus 1 and add, that will be 0. By minus 1 and add, that will be y. By minus 1 and add, minus 2z. By minus 1 and add, that will be 3. Now, what I will try to do, I try to solve these two equations, because I have two equations, two unknowns. So it will be easier for me since I get rid, so I eliminate x. If you look at these equations, I can divide by 3 the first equation. So so I have this system, x minus 2y plus z equal to, I divide by 3, so I have y minus 2z equal 3. They have y minus 2z equals 3. They are the same. So let me do multiply by the first equation by, the second equation by minus 1 and add it to the third one. So I have minus 1 here. I'm doing minus 1 times the second and add it to the third. Let us see what will happen. Yeah, what I will get? I will get 0 plus 0 equals 0. So I get a correct statement. Okay. But also, if I look at the second one, I notice something. I notice that y, I can write it as 3 minus 2z. Not only that, but also 3 plus 2z, sorry. Okay. And also I notice I can find that x is what? 2 plus 2y minus z. So that will be 2. I plug y there. 2 plus 6 plus 6z minus z. Sorry, 2, 4z. Sorry, this is 4z. So it is 8 plus 3z. So I'm getting y equal 3z, 3 plus 2z. And x equal 8 plus 3z. But z can be any value. Z can be any value. There's no restriction in V. So we have exactly infinitely many solutions where my solution, if I want to make it as x, y, z, I write it as 8 plus 3z and 3 plus 2z, and this is z for any z. Or we can write it this way. I let z equal t, so y equals 3 plus 2t, where t is any value, where t is any value, and x equals 8 plus 3t. So you have infinitely many solutions. Okay. Let me move to another problem. This one. Look at this one. Yeah. There is no way to make the first coefficient as 1. So we need fraction. We need fraction to solve the problem. But one trick I will do, I will make the second equation the first equation, and I will tell you why. So I will do the fraction only for one variable. No, I have them. This is 2x plus 7y plus 4z equals 0. And I have this 3x plus 9y plus 7z equals 0. 2x plus 6y. This is, I will keep it the same. Okay. So to get rid of this 3, I multiply the first equation by minus 3 over 2 times the first, and I add it to the second. Yeah, I'll have a fraction, but it's okay. Now, to get rid of this, no need, I need to multiply by minus 1. So minus 1 times the first and add it to the third. So I have a fraction only in one equation. Okay, so that means what? I have, this is, I will keep it the same. Multiply by minus 3 over 2, that will be 0. So I have minus 21 over 2. 9 is 18 over 2, so that will be minus 3 over 2. Okay, am I right? Yeah, minus 21 over 2. That will be, yeah, and 9 is 18 over 2. That minus 3 over 2y. Now this one, I don't have fraction. This is will be 4 over 2 minus 6 plus 7. So it will be plus z equals 0. Good. Now multiply by minus 1 and add, that will be 0. Minus 1 and add, that will be minus y. Minus 1 and add, that will be plus t equals 0. Okay. So from here, now I can do now these two equations. Yeah, yeah, you can do it the way you like. I can do these two equations by getting rid of z. So what I will have, I will have 2x plus 7y plus 4z equals 0. This one will be the same. Multiply by 1 and add. That will be minus, by minus 1, sorry. I need to get rid of z. So I have minus 1 times the second. I add it to the third to get rid of z. So I have 3 over 2 minus 1. That will be minus plus half y. Z will be gone. Interesting. So what I'm getting y equals 0. If I plug it here, I'm getting z equals 0. If I plug both of them here, I'm getting x equals 0. So my solution, x equals 0, y equals 0, z equals 0. That's it. Yeah, the idea of this question, just to tell you, sometimes you need to deal with fractions to solve the problem. Okay. Let me move to this problem, still in 3.1, where he link now solving these system of equations by the differential equation. Remember, we did such a problem if you have initial condition, how to find the constant. So this is mainly the idea, how to find such constant. I noticed that y is a cosine hyperbolic 4x plus b sine hyperbolic 4x. I need y prime. Y prime will be a sine hyperbolic 4x times 4a plus 4b cosine hyperbolic 4x. Okay, now we'll come to the conditions. Y at 0 equals 6. That implies what? 6 equal, or let me write on the other side. I have cosine hyperbolic of 0 is 1, and sine hyperbolic of 0 is 0. So I have a equal 6. All right? A cosine hyperbolic. Yeah, sine hyperbolic of 0 is 0. We have a equals 0. A equals 6. Okay. Now y prime at 0 equal 20. That implies what? Substitute 0, sine hyperbolic 0, 0. I have 4b equal 20. So a for sure will be equal to 5. A will be equal to 5. Okay, so that will fix it. Not A, B, I mean. What is this? I mean B, sorry. I mean B would be equal to 5. So I get A and B as a solution for this problem. Now let me move to Gaussian elimination. This procedure, the elimination, which we did exactly this procedure. First, I need to get rid of this coefficient, like what we did. We can't do it for the matrices. The same thing, exactly. I will show it now to you. So, if you have this system of equations, we can write it in a matrix form, where A is this. A is the coefficient of x1, x2, x3, xn arranged. And then I have this one, it's just the vector, which is the right-hand side. And this one is what? Is A times X. This is the matrix A times X. And it's equal to the vector B. So we have this system. A X equals B. Okay. We can construct, I mean, A, we call it the coefficient matrix, and B, we call it the right-hand side. Okay. We can construct what's called augmented matrix. This is the augmented matrix. What's the augmented matrix? Just I augment A, the coefficient matrix, with the right-hand side vector. We put it in one, like one matrix. This is what I need for the system. Okay. So we need also to talk about elementary row operations. What are these elementary row operations? They are the same operations which we talk about when we deal with the equations. Multiply one equation by a non-zero constant. Same thing here. Multiply any single row, which is an equation. The row of the matrix is the coefficient which is in the first equation. So I can multiply the first row by a non-zero entry. I can interchange any two rows, I can add a constant multiple of one row to another row, which is the elementary row operations, which is the same thing which we did. This is exactly what we will do. Okay, but now when I do the calculation using Gaussian elimination, I will stop if I construct what's called echelon matrix form, because back substitution will give me the answer quickly. What they mean by echelon matrix form, if every row in A, every row of E, they call it E, echelon, from the word echelon, the row which consists of all zeros, I will move it to the end. I will make it, I mean, I will list all the rows with consists entirely of zeros at the end. And this is the most important. In each row that contains a non-zero element, each row that contains a non-zero element, the first non-zero element lies strictly to the right of the first non-zero element in the preceding row. Let me explain it by examples. Look at this. Now, the row which consists of all zeros at the end. We don't have any rows consists entirely of zeros. Okay. Now, if you look, this is the first non-zero element in the first row. If there is a non-zero element in the second row, it should lie to the right of the first one, of the non-zero element in the first row. The third, the same thing, to the right of that. Let me look at this. This one, I don't have non-zero. We don't have zero rows consist of entirely of zeros. We don't know. We don't think about this. Now, this is the first. These are the first non-zero rows. Usually they are one. Look at them. They are to the right of each other as we are going down. The same thing here. This is the first non-zero in the first row. This is the first non-zero element in the second row. This is the first non-zero in the third row. They are lying to the right of each other as I'm going down from the first row to the second row and third row. Look at this one. I have a problem here. These are not echelon form. Why? This one. A row consists entirely of zeros. It's not at the end. So this is not echelon form. Look at this one. The first non-zero element is this one in the first row. In the second row is this one. The second row is not lying to the right of it. Also, if it is in the same column, this is not acceptable. What's are acceptable? Just to be into the right of the first one. The element, the non-zero element, the first non-zero elements in each row should lie to the right of each other as we are proceeding from first row, second row, third row, and so on. So this is not echelon form. I have a problem here. Okay, let me do the system the same way. Oh, by the way, this is the same problem we did before. So let me do it again as echelon. That's Gaussian elimination. What I will do first, what is A? I'll do this in detail. A is 1, 3, 2, 1. What is B? 9 and 8. Okay. And what I'm trying to do, I'm trying to solve the system using Gaussian elimination. I can't do it by the elimination method, the regular elimination method. First, I will find the augmented matrix, which is A augmented with B. That give me what? 1, 3, 2, 1, 9, 8. Usually they put like a dashes line between them. Now I will do the elementary row operations. What I will try to do, I'll try to make it in this format. This is a number. This is 0. This is a number. This is a number. This is a number. This is a number. When I do this, I get rid of the coefficient of x. So I have only coefficient of y here because this is a coefficient of x. This is a coefficient of y. This is the right-hand side. like what we did with the elimination method. Okay, so let us do it. Now, how to do this? How to make this 2? I multiply the first row by minus 2 R1 plus R2 to get what? I have 1, 3. This is 9, same. Multiply by minus 2 and add, that will be 0. By minus 2 and add, that will be minus 5. By minus 2, that is what? Minus 18 plus 8 minus 10. Okay. But this is AX equal B, huh? Now, if we think about this equation or this matrix or this segmented matrix, now I can do back substitution. Is it echelon form? Yeah, let us check. Is it echelon form or not? This is the first. Do you have rows consist of zeros? No. But I have this one, then the first and zero element. This one, the first and zero element. They're lying to the right of each other, which is good. As I proceed from the first one to the second one. So this is now echelon form. Echelon matrix, echelon matrix. I call it echelon matrix. Okay. That's it. Now I can do back substitution, where I will retain the equation. Now look at this equation. I write it as in matrix form. Now we return it back to the equations. So I have x, where I can do the back substitution. Plus 3y equals 9, minus 5y equals minus 10. I notice one thing. In the second equation, I can solve it right away. Y equals 2. I can do back substitution to find x. What will be that? I have x will be what? 3. Huh? 9 minus 6, which is 3. Can check. 3 plus 6, 9. 6 plus 2, 8, which is correct. So my solution, x equals 3 and y equals 2. Yeah. I can do the same for this equation. By the way, those are the ones which I did before, just to show you what will happen. Yeah. Okay, so let us do these things, huh, to see what will happen. Right away, I'll do the augmented matrix. Huh? I'll try to solve them as quick as possible. Huh? Okay, so I have the augmented matrix 2, minus 1, 1, 2, 5, 0. Usually I like the first element to be 1, so I can do the calculation without fraction. Okay, so I can interchange row 1 with row 2 to get what? 1, 2, 0, 2, minus 1, 5. Okay. Now, I need to make this 2, 0. So multiply the first row by minus 1 and add it to the second row. So that becomes what? This is 1, 2, 0. Multiply minus 2 and add, that will be 0. Minus 2 and add, that will be minus 5. Minus 2 and add, that will be 5. Done. Now this is echelon form. By the way, you can do one step, but this is now echelon form. This is, they are to the right of each other. Or you can do one step to make it better. I can say multiply the second row by minus 1 over 5. Second row. What you will get? 1, 2. No need to do it, but if you do it, it will make it easier for you. That will be 0, 1, minus 1. Why it will be easier? Because from right away, this one means what? This equation means y equals minus 1. Plug it here. You will get what? X plus 2y equals 0. So that means x will be equal what? Minus 2 times minus 1, 2. So this is my answer, which I can check easily. 2. X equal 2, y equal minus 1. So I have 4 minus minus 1, 5. I have 2 minus 2, which is 0. Good. Now let me move to this one. Do the augmented matrix. 2, 6, 4, 3, 9, 11. I like this to be 1. So I can divide the first row by, I will multiply it by half. First row. So I have 1, I don't have fraction. 3, 2, 3, 9, 11. Now what I will do, multiply the first row by minus 3 and add it to the second row. What you will get? The first row, no change. Multiply by minus 3 and add, that will be 0. Minus 3 and add, that will be 0. Minus 3 and add, that will be 5. Now, is this echelon form? Yes. Yeah, because everything is okay, huh? It's echelon form. So, but now if you go back to the equation, that will be x plus 3y equal 2 and 0 equals 5. That means what? No solution. Like what we did before. Let me go to this one. That will be 2, 6, 4, 3, 9, 6. Divide by half. Divide by 2, I mean. Multiply by half. 1, 3, 2, 3, 9, 6. Oops. Okay. Now, first row by minus 3 and add it to the second row. What you will get? 1, 3, 2. That will not change. There is no change in this one. 0, 0, 0. Minus 3 times 2 is 6 plus 6, 0. And this is now augmented, and now it's echelon form. So what I shall do, if I return it back to the equation, what you will have? X plus 3y equal 2 and 0 equals 0. So from this one, I'm getting x equal 2 minus 3y. And y is any value. So if I let y equal t, then x is 2 minus 3t, where t is any value. So this is infinitely. I have infinitely many solutions. Okay, infinitely many solutions. The same thing, we can do it for 3 by 3, 4 by 4, 5 by anything. Huh? We can do the same procedure. Now we choose the same one which we did before. That was number 9, huh? Question number 9, which we did before. Now we do it as a Gaussian elimination. So you see both of them. This is 9. What I know, what is it? Where I know the answer should be 4, minus 1, and 3. Huh? So let us do it. Let us do the Gaussian elimination. The same procedure, exactly. Like in the elimination, but now we are dealing with the matrices. So the augmented matrix will be 1, 5, 1. This is 2, 2, 1. Be careful here. Minus 2, 1, 1, 7, 2, 3. Okay. Now, what I am doing, multiply the first row by minus 2 and add it to the second row. Also, multiply the first row by minus 1 and add it to the third row. Let us see what will happen. The first row will not change. What's good about Gaussian elimination? No need to worry about anything. Just now we are dealing with the numbers, nothing else. We're dealing with the coefficients. But exactly this is what we are looking for. Minus 2 and add, that will be 0. Minus 2 and add, minus 10 plus 1, that will be minus 9. Minus 2 and add, that will be minus 4. Minus 2 and add, that will be minus 3. Right? Minus 2 and add. Yeah. Now, minus 1 and add, that will be 0. That will be 2. Minus 1 and add, that will be 1. Minus 1 and add, that will be 1. What I will do, okay, yeah. Yeah, I can do it with the fraction. Let me do it with the fractions. Oops. See what will happen. So I need this to be 1. So first, I multiply by minus 1 over 9, R2. Only R2. So I have 1, 5, 1, 2. This is 0, 1, 9 over 4, 3 over 9, which is 1 over 3. No, this is 4 over 9, sorry. Yeah, 4 over 9. Okay, this is the same. 0, 2, 1, 1. Now, I multiply the second row by minus 2 and add it to the third row. See what will happen. 1, 5, 1, 2. This will be the same. 0, 1, 4 over 9, 1 over 3. Okay, I need to get rid of this. So multiply. Oops. The second row by minus 2 and add it. That will be 0. The same. That will be 0. Minus 2. Oops. Minus 8 over 9 plus 1. That will be minus 1. 1 over 9. Yeah. 1 is 9 over 9. And this is minus 8 over 9. So that will be 1 over 9. Okay. Minus 2 over 3. Which is plus 3 over 3. It will be 1 over 3. I can take care of this. Multiply the third row by 9. What you will get? 1, 5, 1, 2, 0, 1, 4 over 9, 1 over 3, 0. Multiply by 9, huh? So it will be 1, and this is 3. خلاص. Now we're ready for the back substitution. I have from here z equals 3. Plug it in the second. Plug it there. I have there what? Y plus 4 over 9 z equal 1 over 3. So y will be equal to what? 1 over 3. If z equals 3, that's 4 over 3 minus 4 over 3. That will be -1. Now plug everything in the first equation. So x will be 2. Let me do it quickly. 2 minus 5y minus z. And that will be what? 2 minus 5, 2 plus 5 minus 3. So that will be what? 4. So I have the answer z equal 3. Let me start with x. Yeah. X equal 4, y equal -1, z equal 3. That was my answer. For the elimination, I'm using the same z equal 4, y equal -1, z equal 3. Exact. Okay. So I think that explain it. We have some problems to do. Yeah. Let me do these. Then I will stop. Okay. Because this one we have no solution. The other one we have infinite solution. Let us do it. So I have 1, 5, 6. This is 3. Sorry, we should use the other color. I will complete it, no problem. Okay. 5, 2, 10, 1, 8, 17, 8, 5. What I will do now? -5 R1 plus R2 minus 8 R1 plus R3 to see what we will get. This one, no change. This one multiplied by -5 and add, that will be 0. -5 and add, that will be -23. -5 and add, that will be -10. Sorry, this is -10. Huh? Be careful with the minus. That will be -40. -5 and add, that will be -14. This is -8 and add, that will be 0. -8 -23. -8 and add, it will be what? -40. -8 and add, -24 plus 5 -90. Now, if we look at this one, I notice in these two are the same. So I multiply the second row by minus sign and add it to the third row, I'm getting something. I think that will finish the problem. So I have 1, 5, 6, 3. This one, I will not change it. I can divide by -23, but that will give me a fraction. I cannot multiply by minus and add that. Yeah, by minus and add, that will be 0, 0. By minus and add, that will be -5. Look at this one. I have problem here, clear problem. That I have 0 equals -5. So right away, no solution. Let me do this one. The last one, just for this video. Let me try to do it quickly. 1 minus 2, 1, 2. Okay. 1, 2. This is 2 minus 1 minus 4, 13. 1 minus 1 minus 1, 5. So multiply the first row by minus 2 and add it to the second. Multiply the first row by minus 1 and add it to the third. What you will get? This will be the same. Minus 2 and add, that will be 0. Minus 2 and add, that will be 3. Minus 2 and add, that will be minus 6. Minus 2 and add, 13 minus 4, which is 9. Minus 1 and add, that will be 0. That will be 1. Minus 1 and add, that will be minus 2. Minus 1 and add, that will be 3. I can divide the third row, multiply it by 1 over 3. The second row, I mean. I have 1 minus 2, 1, 2, 0, 1 minus 2, 3, 0, 1 minus 2, 3. Now what I will do, multiply the second row by minus 1 and add it to the third row. What you will get? 1 minus 2, 1, 2. I have, this is the same, 0, 1 minus 2, 3, but that will be 0, 0, 0, 0. So the third row will be gone. So if I do back substitution, what I will get? Here I get 0 equals 0. Nothing to worry about. But here I'm getting what? Y minus 2z equals 3. And here I have x minus 2y plus z equal to. Very clear to me. I can write y in terms of z and x in terms of z. So I have y equals 3 plus 2z, and I have x will be 2 plus 2y minus z. So I have 2 plus 6 plus 4z minus z, and that will be 8 plus 3z. So for sure we have what? We have infinitely many solutions. I let z equal t, y will be 3 plus 2t, and x will be 8 plus 3t. Yeah, you can do the same for, now we have 3 equations, 5 unknowns. You can do the same procedure exactly. Like in this one also, 3 equations, 5 unknowns. By the way, what we need for our course, for the next section, for chapter 4, we need where we'll get a solution, x equal 4, and we will get any solution. But in chapter 6, 7, and 8, we need usually we have a system where we have infinitely many solutions. Let me stop the recording. Yeah, I'll stop the recording. I don't like, so I think these 2 videos will be more than enough to explain elimination and Gaussian elimination. Thank you.